This chart is about vectors and about how you can think about vectors in a visual manner, that would be graphical vectors, and how you can think about them in an analytic manner, and that's the component way of thinking. So essentially, um, on this chart, the red ink is mostly having to do with the components, and the black pencil is the graphical vectors. So let's begin by drawing two vectors, a vector A that's 76 millimeters long and inclined 25 degrees with respect to the horizontal, and a vector B which is 50 millimeters long and inclined 6 degrees with respect to the horizontal. So over in this first drawing here, I draw the vector A, just copying it basically from here over to here, and then when A ends, I then tip to tail I draw B, and the vector joining the beginning of A to the end of B is defined to be A plus B. That's the graphical vector A plus B. And so here's A plus B. I could have done it in the other order. I could have done B first and then A, and I would have gotten the same vector. So convince yourself by looking at these two pictures that you get the same vector. Graphically, if you um, add B plus A or A plus B, in other words, vector addition is commutative. Then in these last two pictures, I draw A minus B, and so the way we're going to do A minus B is we're gonna instead of subtracting B, we're going to add the negative of B, which is the same thing. So the negative of B, if you look at B up here, and negative B is the vector that is the same length as B, but anti-parallel to it. So it's pointing the opposite direction. And so here's A redrawn, and here's minus B. This vector right here, for the beginning of A to the end of minus B is A minus B. And then finally, B minus A, along the same lines as what I've done here, is B minus A is the same as B plus minus A. And so I'm going to start with B. Here's B vector, and here's minus A. Minus A is again the same length as A but anti-parallel to A. And the vector that begins at B and ends at minus A is B minus A. And so you can look at these two vectors and you can see that these two vectors are the same length but they are anti-parallel to each other. In other words, if two vectors are anti-parallel to each other, one is the negative of the other. And so this vector is the negative of that vector and vice versa. So graphical vectors are an excellent way to attack a problem conceptually and set it up. But we want also to be able to do things with precision, and in order to do that we generally use vector components. A vector is this vector, which I can express as 76 millimeters cosine 25 times I vector being the unit vector in the positive x direction, plus A vector, the sum of these two vectors is A vector, and A vector, AY, is 76 millimeters times the sine of 25 times J hat. J hat is the unit vector in the y direction. And so if we compute the cosines and do the multiplications, A can be expressed in component form as 68.9 millimeters I hat plus 32.1 millimeters J hat. And so the 68.9 millimeters I hat is this vector going in the I hat direction, and 32.1 millimeters J hat is this vector going in the J hat direction. We can do the same thing with B, and in this case, again using the cosine and the sine to project respectively the x and the y component of the vector, we get B is equal to 49.7 millimeters I hat plus 5.2 millimeters J hat. And so now, when we go and do a plus b, we can, so when we add a plus b together component-wise, it's simply a plus b is the sum of the x components of the two vectors times I hat plus the sum of the two y components of the two vectors times j hat. And so this would then be 68.9 millimeters plus 49.7 millimeters I hat, which is 118.6 millimeters I hat, and 32.1 millimeters plus 5.2 millimeters times j hat, which is 37.3 millimeters times j hat. If we find the length of these vector a plus b using components, that's through Pythagoras, that's just going to be the square root of the sum of the square of the x component plus the square of the y component, which turns out to be 124.3 millimeters. Now, when I did the graphical vectors, I actually scaled everything and measured it, and I get 125 millimeters, pretty close to 124.3. So you can get some feeling for the inaccuracies which creep in with graphical vectors looking at this comparison. Also, I can do the same thing with the angle. The angle that I measured on the graphical vector a plus b is 17 degrees, and using the more precise component math, theta is going to be the inverse tangent of the y divided by the x component, which is 17.5 degrees. Again, fairly close. This component calculation is more accurate. The second one I won't do in detail because basically the component arithmetic produces exactly the same results, and it's a good way to see why, analytically anyway, vector addition is commutative. Okay, so for these last two guys, a minus b is, okay, so I take 68.9 minus 49.7 and I get 19.2 millimeters I hat for the I component of a minus b. And for the j hat component, I get 32.1 minus 5.2, which is 26.9. And the length of a minus b is 33.0 millimeters. Let's see, I measured 34 millimeters here with a rular, and the angle is the inverse tangent of the y component of the x over the x component, which is 54.5, and I'm measuring 54 degrees. Okay, and then for this last one, b minus a, so each one of these is going to get reversed, and so instead of having 68.9 millimeters minus 49.7, you're not going to have 49.7 minus 68.9. So the I hat component of b minus a is negative 19.2, and the j hat component is going to be the negative of this, and the length is going to be the same. The theta now I'm measuring from the negative x direction, and it's 54.5. It's going to be the same angle here, except it's downward with respect to the x-axis, negative x direction, instead of being upward with respect to the positive x direction. And so these two vectors geometrically are negatives of one another. So we'll have much occasion to do this in the next several weeks when we deal with force and momentum. Those are going to be several of the examples. We also, of course, have velocity and acceleration and displacement.